if a tree has fallen in a forest and there is no one around it to hear the sound, does it make any sound? That is the question. Okay, so answer to this question is known to you, but this is a topic of discussion in physics as well as in philosophy. Because you know that there are two perspectives from which any event is considered or analyzed. One is called classical perspective, means here there classical physics, laws of classical physics are used, and there is one more perspective that is called quantum mechanics. So if you think of this problem, whether the sound is heard by anyone or not, whether the sound has produced or not, that is the question. Okay, once again I am repeating the same question. If a tree has fallen in a forest and there's no one around it, does it make any sound? So you know that answer to this question is yes. If there is an observer, he must hear the sound of falling tree. But according to quantum mechanics, if observer is not present over there, then actually no sound is produced. According to the principles of quantum mechanics, this is the result. So according to classical physics, how this problem is analyzed? Since the tree is falling to the ground, so when it is falling, the tree is creating vibrations in the air, and the particles of air produce sound due to its vibrations. Okay, and if an observer is present over there, that observer must hear the sound. Means that observer would be able to hear the sound of the falling tree. But according to quantum mechanics, you know that principle of superposition is there. Any system or any quantum system always exists in a combination of so many states simultaneously, so many possible states. So if we talk about the falling tree, then what are the outcomes? What may be the outcomes? First one is the tree has fallen. Second one is the tree has not fallen. Third one is the tree has produced sound during its falling. Okay, and the fourth is tree has not produced any sound. So four outcomes are there according to quantum mechanics. Okay, if you think of the same problem from this perspective of quantum mechanics, then there are four outcomes, and only one outcome can be observed if an observer is present over there or if any measurement is made. Means you know that any quantum system, the particles or the quantum system is described by a wave function, and the wave function represents the probability amplitudes of all the possible outcomes. It remains in a state of superposition of all possible outcomes. And whenever a measurement is made or whenever an observer is observing the event, immediately the wave function collapses and only one outcome is observed or is measured. Okay, so from the quantum mechanics perspective, if you think of the same problem, that is problem about the falling tree, then there are four outcomes and nothing can be predicted with certainty. Okay, but according to classical physics point of view or perspective, the answer is known to you. It is known to everybody. Since the tree is falling, that means it must produce sound, and that sound must be heard if an observer is present over there. Or if any measurement system is there, then that measurement system can easily capture the sound or record the sound or hear the sound or sense the sound. Okay. So I have discussed here the two perspectives for the same problems. For the same problem, that is problem about a falling tree. Okay. And you know that in quantum mechanics there is one term called quantum coherence. Then interference is there, quantum interference, such as in double slit experiment. We have seen quantum interference of particles like electrons. Okay. Interference pattern is observed. So that is the case of quantum coherence. So when quantum coherence exists in a quantum system, in that case the interference pattern can be observed. Okay. And if quantum coherence does not exist, means in case of quantum decoherence, the interference pattern cannot be observed. Whenever a quantum system interacts with its environment, in that case the quantum system loses its that special characteristics or special property of superposition. Okay, so this was all about today's lecture, and the topic was the discussion of two perspectives for the same problems. Okay, anyway, so this is the end of this video. Thank you for watching this video.